Alright, time for another draftphysics.com, debatephysics.com also. Video presentation. Yeah. Anyway, so Paul Nord, it's probably the last response from him, it would appear anyway. So we'll go through it in a little more detail and examine all of the different experiments that can be done to clearly demonstrate that kinetic energy never does any work. It never works. Simple enough statement. So they can't show an experiment where it actually does work, in the sense that an experiment that is credible, in the sense of recognizing different variables. So yes, they can create a facade, a fake kind of circumstance where they're pulling a weight down or doing something else to fiddle with gravity to make it appear as, oh, it's just the same amount of, man, it's not the same amount of energy at all. Okay, so they're cheating. But any plain experiment, tug of war, banging stuff into other stuff, any crude, real, raw experiment, kinetic energy never works, never provides any, never transfers anything called motion or action. It doesn't convey it consistent with what they state it to have. All right, so I'll read his comment and then do my comment and then draw as I read my comment. That'll be, I think, the way it'll go. Yeah, why not? All right, so he had stated, and I had quoted him, okay, he stated, we build bridges, we make cars better, we fly planes. And I said, we also landed on the moon, not using the kinetic energy theorem. And then he says, I'm pretty sure kinetic and potential energy are critical to solving the tyrannical rocket equation. So the rocket equation, oh, I'll read his thing and then I'll respond. Okay. All right, so then he quotes me as saying, you have no credible experimental evidence. You haven't linked to anything relevant. Show me a lever not conserving momentum. Show me it taking 25 times the energy to spin something 5 times as fast. And then he says, I described a couple of experiments where we test this in the freshman lab, and I debunked those. I made videos explaining, so I'll explain it again because it just proves the point. They have no counter argument. Okay. The first lab is projectile motion. Proves my point. Okay. And the final lab in the semester is a ball rolling down an incline. So this just demonstrates that they all have just this formula. I kind of showed that with Professor Lewin, where he's just doing experiments that were done in the 1960s. The exact kind of framework. Let's put a monkey up in the air and shoot the monkey. Same exact formula. And, I thought Professor Lewin was being creative. And no, they're exactly redundant experiments that have been done for 50 years. It's just a formula of their physics and how to teach it. And it has nothing to do with really demonstrating or showing you the truth because they don't modify the experiment a little bit. The conservation of energy predictions allow you to describe the motion precisely. So that's just nonsense. So, yeah. The projectile case, the initial velocity and angle precisely determine the maximum height of the launch. Yes, that's also the velocity of the launch is precisely twice the velocity, not 4 times the velocity. And again, you're saying somehow it takes 4 times the energy to go twice as fast, which is, on its face, nonsense. All right, in the rolling ball case, you need to consider that a fraction of the energy goes to the angular motion. Yeah, that's exactly what I said. Now I say it again. That's exactly my argument. For a solid ball, this will be a ratio of 5 to 7. And it won't matter because if you take the 5 and add the 2, you'll have the same amount of velocity. So the velocity in the end of the roll will be smaller than you would have gotten if you dropped the ball from the same height. No, it'll be the same. It's just as you have to add the angular momentum to the linear momentum, and then you'll have the total momentum. So just not true what he said. Okay, you're free to sign up for our lab. So, again, it's just so obnoxious. It's just so arrogant. They don't deal with any of the real arguments. They just run away from the conversation and proselytize their shit religion. Or any physics lab anywhere. Right, and I can learn about wave-particle duality and all the other nonsense that you morons preach, perverting young minds with your gibberish. Our conspiracy to teach mechanics correctly is vast. Yeah, force is with you. Not. Alright, so let's do the first one. I'm pretty sure the kinetic and potential energy are critical to solving the tyrannical rocket equation, I point out. The only thing complicated about the rocket equation is the moving target of the fuel consumption, so the rocket's getting lighter. Now, it's also true the rocket starts going faster and faster, the relative difference between the velocity of the exhaust and the velocity of the spaceship starts to change. But again, it's kind of marginal. You're talking at best, you know, a 5% difference in the speed, which isn't big enough to make that big a difference. If you narrow the subject to navigating something like a lunar module, there is no complication. So yes, let's stick to the less complicated, not going through atmosphere bullshit, and just say what's the basic function of moving a spaceship. And the basic function is you throw out something with a momentum and you get the equal and opposite reaction. You throw out something with kinetic energy and you only get the opposite reaction of the momentum. Momentum steers, momentum moves. Kinetic energy does absolutely nothing. Fact. Momentum of thrust lets you know what you can expect as an opposite reaction. Calculating the kinetic energy of thrust will be of no value at all. Just an absolute fact. So we'll draw that again. Okay. Just to emphasize, no one's going to counter the argument. No one's going to explain how no kinetic energy works. Because it factually doesn't. Alright. So, drawing device, where is it? Here it is. Okay. Oh, I got to do the focus thing. Alright, so, we just use, you have some thing in space. We just make it a round thing. Who cares about spaceship in this circumstance? Something, just a lunar module. There's no air resistance. Shape is irrelevant. And all you're saying is, how do I move this thing? Alright, and from an internal position, I have to create some sort of explosion, or I have to throw something away. That's the only way to do it. So if I throw bits of myself, okay, out, alright, I have a bag of tennis balls with me, and I throw a tennis ball away, okay. The fact is I can throw it at a high velocity, 1,000 miles an hour, or I could throw it at 1 mile an hour, right? And we could pretend the weight is very light, one mass, or we can make it very heavy, 1,000 pounds. I fill it with lead. All right, so we have a huge difference in the kinetic energy. We have 1,000 times more KE here. Okay, the number calculates out to be 1,000 times. So if this is 2, this is 2,000. If this is 4, this is 4,000. And the absolute fact is, right, the only thing I'm going to get as motion, okay, is the MV. Whatever the MV was here, which will probably be, let's say, is 2. Okay, this was 2. And that's the absolute truth also. These two things require the same momentum. They calculate out to exactly the same momentum. And that's exactly what I'm going to get as my opposite reaction is 2. It's perfect. There's absolutely nothing flawed in that analysis. It actually demonstrates quite completely and perfectly, like the balancing balance, the gravity balance, the lever balanced in gravity. It perfectly proves the point. It proves what is equal to what. It proves that this kinetic energy number will do you absolutely no good. It won't mean anything. It won't tell you anything. It will be just a rubbish number, a statement about some sort of energy that you cannot possibly collect. And the same, ironically, is true if these objects hit each other. They already know this is true too. That I can't, the only part that's a little bit doubtful is the game they play with elastic collisions. But we know if, say, a little particle of something flies into space and it hits, It's not going to matter what it's, and it sticks. It's not going to matter what its kinetic energy is. This is just the ballistic pendulum all over again. This is the adding 5 pounds to a 5-pound car. You add 5 pounds and you end up with a 10-pound going half the velocity. It always turns out that way. All the kinetic energy, as a number, just disappears. It's half the kinetic energy, but I mean, the point is it just reduces to momentum again. You don't even collect half the kinetic energy, technically. You're just collecting the momentum. That's all you can collect. So it doesn't matter what it is. It doesn't matter whether it's really big and going really slow, or it's really small and going really fast. If it sticks to that space object, all it's going to give it is the MV. That's it. That's all that's going to go in, is the MV. Nothing else. Nothing else. I mean, it's a decisive argument. Please, somebody, explain to me how it happens some other way. All right, and so what their argument is in this one case, let's just draw it for the sake of it, because it's, it's nonsense. Their argument is if I throw something at the spaceship and it bounces back off with the same speed it came in, so it totally reflects. So it comes in with 100 momentums and it bounces off with 100. That somehow, yes, the kinetic energy got into the object and now has 200 momentums. They'll have that kind of argument, which doesn't happen in space, so we don't have that experiment either. Okay, they haven't done that experiment where they show us how you can just throw something at something else in space, throw a small thing at a big thing in space, and the big thing flies off with more momentum, and you get back everything you started with. We don't have that experiment because it doesn't frickin' happen. They haven't done that one in the shuttle. All right, so I'll just go back to the next point. All right, you can do that by just pausing, I imagine. All right, so Paul states, I described a couple of experiments where we test this in the freshman lab. Hilarious. And I provided a counter argument explaining the flaws in your experiment and your reasoning. Gravity is a time-dependent force. Okay, so let's do a little bit on that. Why not? Pause. Yeah, probably didn't need to pause, but anyway. Yes, I already erased. All right, so the experiments they're talking about, again, are always these kind of silly, pulley kind of things, where, they move a cart. And I have explained that obviously this pulley will fall really fast. Okay, so that means it goes through the gravity very quickly if this is very light. And if this is very heavy, then this falls really slowly, really slowly. Okay, I don't know how to draw really slowly, but yes, it falls really slowly. And the slower it falls, that means the more time it was in the gravity, more time. So the gravity was making it weigh its full weight for a longer period of time. That means the full weight on this string, okay, was the full weight of the object and more time at the full weight. So obviously more energy got into this if it's heavier. So the heavier I make it, the more energy it collects in total, the more momentum it collects, because it's in the gravity longer, because gravity is a time dependent force, in that it's in 1 second units. Is how that number can't be 9.8 unless this number is 1. That's the absolute truth. Okay, so you can't pretend this is just seconds. It's 1 second. So that's how they cheat the math, is they just put an S down here and pretend, oh yeah, the 1 is there. But if you don't put the 1 there, then they can do all kinds of canceling cheats and all kinds of other nonsense and create seconds squared. But if they have a 1 stuck in front of it, well, then they're stuck, because then they have to actually multiply the 1, and they can't multiply the S times the S. They have to multiply the 1. Yeah, and so it's that obvious and simple. It's a time-dependent force. It's all about how long the force is hitting you and affecting you, and it really doesn't have anything to do with distance per se. I mean, distance is important, but it's not important. Like, say, obviously, if I move something faster than gravity, faster than the free fall speed, then this can't possibly gain any extra momentum from gravity. If it's going 1,000 miles an hour, the 9.8 distance of 1 meter isn't going to be 1 second. I mean, 10 meters isn't going to take 1 second anymore. It's going to happen in a matter of a millisecond. So the added velocity from gravity is going to be 1/millionth of that 9.8, or 1/1000th of it. So it's going to be a tiny contribution. And the same goes for going against gravity. So if I can go fast enough through gravity, going up, I can go much further on less energy because I'm in the gravity less time. And so it's as time dependent as raindrops falling, you could argue, or a stream flowing, or a wind blowing. It's just about how long you're collecting the force will decide how much energy it can give you. Fact. Fact. Alright, so let's see if he does the other argument. And I have provided counter, gravity dependent force. Let's see, the first lab, projectile motion, we did that. We did do that? No, we didn't do that. The first lab is projectile motion, and the final lab of the semester is a ball rolling down an incline. So I argue the ballistic pendulum that can only collect momentum provides a very good counter argument and counter evidence. Of course, levers and pulleys and gears also provide substantial proof. So I'll illustrate the thing he's talking about, the projectile motion. Because I don't think the rest of this contains that, so let's just do that one real quick and such. So I have to do this. Yeah, I did it and it didn't work. What do I do now? I don't know. Anyway, yeah, so he's arguing that this case proves it. So you have a cannon or whatever, and you shoot a cannonball up. And it has a trajectory, and how high it'll go, its peak height, can be calculated using their math. But yes, of course, it can be calculated using my math just as well. And we already know this fact, okay, that the distance, all right, twice the velocity is going to get you 4 times the distance. So we already know this is a truth. So it's not that complicated. And his real argument is that twice the velocity requires 4 times the energy. So that's the part you have to say. Do you really believe that? Do you really believe that you use twice as much gas going 20 miles an hour than you use when you're going 10 miles an hour? I mean 4 times as much. Do you think so? 4 times as much gas to go 20 miles an hour versus 10 miles an hour. And it just gets more and more extreme. So this is where I bring up the point about 25 times the fuel to go 5 times the velocity. Ludicrous argument, frankly, on its face. Just absolutely no evidence of anything like that ever happening. They can't link to any clinical experiment demonstrating anything like that, and yet they just keep preaching it. And so it's an argument against their argument. Saying that you can play with your MGH formula, okay, is not explaining that, oh, wait a minute, I forgot to tell you that gravity is a time-dependent force. So, yeah, it will. You can play this game, and say that somehow kinetic energy happens, but it doesn't show itself when you actually try to do the experiment and collect it. So again, if you want to believe that twice the velocity takes 4 times the energy, that when something falls 4 units of distance, that it's actually going to collect 4 units of gravity, when clearly you can understand that in the first unit of time it just gets this, and in the second unit of time it gets all of this, that it's going half its speed here, 3/4. I mean, that's a huge giveaway. When something's going 3/4 of its speed somewhere other than the middle, you know that somehow something's not linear, that something's changed, in the circumstance. And the simple truth is that obviously the object gains more velocity and travels more distance in the second, the second unit of time. It travels much more distance because it's already acquired a velocity and it's going through the gravity faster. Duh. It's really, these things, this shouldn't be an argument. People should just, they should just concede and say, okay, our theory is quite incomplete or something. I just can't believe they'll keep defending, these premises that they're just obviously not true. These assertions. All right. The conservation of energy predictions allow you to describe the motion precisely. So I say, only in your statements, not in evidence. Show me a lever actually conserving kinetic energy. Again, so they're making arguments that they have this precise evidence or this precise theory, and there's no evidence of any precision. And if you actually analyze the experiments precisely, okay, you'll see that it never works. That you can't ever collect kinetic energy by attempting to absorb it. So the ballistic pendulum, I guess I'll draw it real quick. They're all the same experiment. The lever, the ballistic pendulum, they're all telling you the same thing. This is what I have to do. So again, as I stated, the ballistic pendulum is basically just this argument all over the place again, where you're just changing, okay, how much mass you're moving. Okay, you add 5 to a 5, it has a velocity of 10, and you end up with a 10 going 5, and so all of the momentum is conserved, and you've lost 1/2 of the kinetic energy. In truth, there was no kinetic energy, because all you've done is shown that you can't conserve the momentum precisely. And the same is true, so the ballistic pendulum is just really the same argument. You're just taking a projectile that has the motion, and you're saying, let's share it with this other object. All right, and what do I get as a total coming out? Well, I'm going to get whatever that momentum was. So the mv is going to precisely equal the mv in. And there's going to be no sign of kinetic energy. So it doesn't matter what the kinetic energy of the object is. It doesn't matter how big it is. Doesn't matter what its mass is. Doesn't matter what its velocity is. It just matters what its mv is. So it has a m and a v, or a m and a v. It's going to just be converted into mv, the same mv. The product will just be what you started with as a mass and a velocity. And that's what every single ballistic pendulum experiment demonstrates. That's what every single inelastic experiment demonstrates. Every single time you absorb the energy something has, you only convey the momentum. You can never convey any kinetic energy at all. That should be telling you, this is how you can't get collecting energy any simpler. This is the ballistic pendulum is just saying, I'm a collector. Please give me your energy. And it can't collect it. It can't find it. All it can find is its momentum. And it finds all of it. Now, ballistic pendulums using bullets, you're not going to get all of your momentum back. You might only get 85% because there's a lot of heat and waste. But in this experiment, you're going to get 100% of your momentum. You're not going to lose anything. And these are facts. And the lever is another good example because it's just saying exactly the same thing. What you put in over here, you're going to get back out over here if you put your objects in the right place. So if you drop a heavy object there and you set a light object here, you're going to put MV in and you're going to get MV out. Okay, you're not going to conserve kinetic energy. And the only loss you have is the weight of the lever. You do have to move the lever, so you have to consider that's going to be a little bit of lost energy. So you have to calculate your placement of the object probably a little bit to compensate for the fact that you're not going to keep all of this energy. All of this energy isn't going to get into this because you move the lever. So you have to understand that maybe it's not going to be twice the distance. It's going to have to be a little closer. Because it's going to be a little bit less velocity is going to be your peak velocity. Come on. This is such elementary physics, and it's just obscene that these people won't argue all of these arguments. They won't explain a single one of these experiments and explain where I've just said something entirely wrong. That doesn't happen. That they have an experiment that shows what I just said is wrong. They don't have it. All right, so where were we? Let's see. All right. In the projectile case, the initial velocity and angle precisely determine the maximum height of the launch. So we already did that experiment. That's just the launching thing, and it just proves my point. Twice the velocity, 4 times the distance. All right. So we know, I know, that twice the velocity isn't 4 times the energy. I know Mythbusters proved essentially they went to the trouble to crash a car at 100 miles an hour and crash a car at 50 miles an hour, and the car crashed exactly twice as much, not 4 times as much, exactly twice as much. Game over. All right. Let's see. And I said, and it's only through understanding that momentum is in charge that you predict the velocity will be 1/2 after 3/4 of the trip. So as I just pointed out, obviously I could roll something and at 2 speeds, twice the velocity. I roll something at twice the velocity. It travels 4 times the distance, but it's going half its velocity 3/4 of the way down the track. Not halfway down the track, 3/4 of the way down the track, indicating that somehow it only lost 1/2 of its velocity over 3 times the distance, which makes no sense at all, unless you understand that, the higher velocity meant less friction, less contact with the surface. It lost less energy to the surface per inch. I pointed out it's exactly the same as thin ice. You slide across thin ice. The reason why you can get away with it is because the faster you go, the less you weigh. Gravity doesn't have enough time to make you weigh your full weight, so you weigh a lot less per inch on the surface. All right. In the rolling ball case, you need to consider that the friction of the energy goes into angular motion. So again, if you roll things, it's the same things as dropping things with the string, rolling. The longer they take to roll down the ramp means they're collecting more angular momentum. So things with their mass on the outside will roll slower than things with the mass on the inside, because it's a lot more energy stored in mass on the outside, and the energy has to be put into it. It takes time to put the energy into it because it's going to have it when it gets to the bottom. So it has to take longer because it needs longer to collect the energy necessary to roll something heavy. To roll something that has the mass on the outside, it's more momentum to roll that object. It's heavier to roll. Okay, even though its mass is the same, its weight is different, just like the lever. All right, as stated, gravity is a time-dependent force, and the longer you take to roll down the ramp, the more force you will collect, and quite obviously not all of the force reveals itself as linear motion. So if all you're watching is how fast it leaves, and you're not paying attention to how much energy is in the mass distribution of the angular momentum, then you're not going to get a right answer for the total energy that the object has. So again, obviously, the one with the weight on the outside might be rolling a little slower, but it has a lot more energy in the fact that when it hits something, it has a lot more angular momentum to give to whatever it hits. All right. Some of it is stored as angular momentum and will only be seen when you extract the energy through friction or collision. So you can't just watch it and say, oh, it has a velocity and that's it. No, it has a velocity for its total mass, and then it also has angular. It has a flywheel called a wheel. All wheels are flywheels, essentially, and they are storing energy. You go back to the Veritasium wind car thing. Again, just a nice big flywheel that they turned into a sail. So when the pitch of the blades is neutral, it's a sail collecting wind. And then when they pitch the blades, it's a fan blowing wind. All right. For a solid ball, this will be a ratio of 5 to 7. So the velocity at the end of the roll will be smaller than you would have gotten if you dropped the ball from the same height. And that's all good physics, I'd say, yes, to recognize that there is this component that I didn't take it into account 2 years ago. I didn't think of it. But yeah, it's just a fact that there's a difference in every object you put and roll. Every one of them is going to have stored a different amount of momentum in angular rotation. And you have to collect that carefully. Alright, total momentum requires combining both linear momentum and angular momentum. So that's all I need to say. And so you're really just saying, how long did it take to fall? The longer it took to fall, the more energy from gravity it extracted, and the more energy it's going to have when it hits something. Alright, you're free to sign up for our lab, or any physics lab anywhere. So just, why would I sign up to a religious course with no evidence? It's like saying, yeah, I could sign up to go to the Catholic Church and listen to some sort of, I can watch them with their smoking urns and all kinds of bullshit. And why would I waste my time doing that? Your physics is no better than that. It's nonsense. It's worse because it's you're pretending it has something to do with science and logic and reasoning and evidence, and it has nothing to do with those things. It has to do with dogma and stupidity and belligerent elitism. Okay. And you're free to continue misrepresenting the truth regarding the depth of experimentation that has taken place. Unfortunately, that freedom has turned science into rubbish and created idiocracy, helped fuel any idiocracy. Nothing has to be the truth anymore. It's just what you can sell to morons. And that's what you've turned physics into. Just entertainment for morons. Because anybody with a brain is going to recognize that you're just talking shit that you made up. It's just a religion. Okay. Our conspiracy to teach mechanics correctly is vast. So at least you got it right in the sense that there's a vast amount of something going on, and what it is a vast amount of bullshit. Okay, just complete misrepresentation of the truth, slander of previous scientists, and to sell a dogmatically silly religion. What is vast is your misreputations and slander. So again, he spent 3 weeks slandering Stephen Mould, who was making exactly the same argument he made, in terms of kinetic energy is conserved by levers. So even though there's a 2,000-year-old law of the lever that says momentum is conserved, they're claiming they somewhere rewrote that fact somewhere. So it's not rewritten in the annals of physics anywhere, but they say they rewrote it somewhere. And kinetic energy is conserved by levers, which is just complete nonsense. Just zero evidence that that's true. What you have is a lot of dogma and arrogance. You are a profile in scientific failure. And he's a teacher. That's the disgusting part. He's just a child molester. He's just molesting young minds with gibberish and nonsense. And that's a sad commentary on our civilization and such. Alright, so maybe that's enough of a video, right? 33 minutes. Yeah. I want to do a Sabine Hassenfelder video just because she's doing a whole little rant about how the foundations of physics, but she really doesn't even know what the foundations of physics are. Hilarious. And such a hypocrite. I mean, she fed at the trough for years. And then when she gets a successful YouTube channel and doesn't need to feed at the trough anymore, all of a sudden she becomes a mocker of the trough feeders. Hypocrisy. Anyway, until the next time, so we'll leave it here. And such. So I guess this is the end for Paul. I'll send him a link to this video and we'll see if he, if there's anything else he'd like to say. But I'll always just throw in my last words anyway, so yeah, he's not going to win. Not a chance. We've got your number, buddy. And your number is lying coward. Yeah, that's your number.